Hello friends, welcome to our channel Knowledge Amplifier, and today we are back with another interesting concept related to generative AI on AWS. So already in our previous video we covered the concept of RAG, that is retrieval augmented generation, right? So what we do in that process basically is we train our foundation models using companies' private data like HR document or some text file, PDF files, etc. And then we can ask some question to the foundation model, and using RAG algorithm the model try to reply based on the information whatever it find out in that particular PDF or text file which are related to the question asked by the user, right? Now in this video we are going to explore how to create a RAG application if our source data is basically some sort of scanned document or image file. For example, if you consider this is one PNG file and this is related to the Apollo mission. Like here it is written the purpose of the Apollo 11 mission was to land men on lunar surface and to return them safely to Earth. And related to this particular mission, the description is available in this particular image, which is nothing but a scanned document also, you can understand. And now suppose we want to train our foundation model on top of this particular image. So how to do that? Let us try to understand. Okay. So obviously, I hope you can clearly guess it that we cannot directly feed this particular image as input for our RAG application so that it will be getting trained on that. Rather, what we have to do is first we need some mechanism using which from this scanned image or scanned document, we can extract the text, and then we can use that text data to train our foundation model. Okay. So now the problem statement boils down to how to extract the text from image or scanned document, right? And obviously, as I discussed earlier, that OCR concept or optical character recognition concept can help us to solve this particular problem. And I have explained some theory and practical implementation using MATLAB in my previous videos. The reference links also I'll be providing in the description box. You can check there if you want to get some better idea out of it. But in this video, let's specifically focus on how to implement OCR or how to extract text from image or scanned document using AWS. Okay. And for that, we are having a service, and that is Amazon Textract. Okay, so text extraction, combining these two words, it became Textract. Kind of that you can understand. So this particular service can help us in automatically extraction of printed text, handwriting, layout elements, and data from any documents. That document can be image file or it can be some sort of PDF files also, right? From all these kind of documents, if you want to extract text data, then this service can help us. So without any further delay, let's directly jump into practical with this particular service, and then we'll eventually explore how to integrate this Textract service with LangChain to implement a RAG pipeline where our data source is scanned image. Okay, so here what I will do, I am having my S3 bucket, like this particular bucket I can use, and here I can upload this image, okay, text to Textract, which is basically having this Apollo mission description, and here I will click on upload. Okay, now here to apply Textract service on this particular image, we are going to use Python code, and as we all know that we need Boto3 to interact with any AWS service from Python, right? So here I will use pip install Boto3. So let's run it, and now let us try to explore how to call this Textract using Boto3. So for that I will open Google and I will search it. So here I have searched Textract Boto3, and let's go to the first link available, which is basically opening the Boto3 documentation for Textract, and here you will be getting a method detect document text. Basically this helps in detecting and extracting different text from image file or PDF files, etc. So the allowed formats also it is providing JPEG, PNG, PDF or TIFF. These kind of documents we can provide as input for text detection from any document. And the code will look like this. So I will use this code. So as a first step, I will import Boto3. Okay, and then I'll paste this code. So this document is not needed. S3 object, because our data is available in S3. So the bucket name I'll be choosing from here. And the name of the image file is text to Textract, this thing. So I'll put that. There it is getting distorted. Let me delete the version first. Then I will take the image name from here. So this is the image name or key we can consider for our S3 object. and here client we need to create for Boto3. So client equal to Boto3 dot client, and here we are going to create the client for Textract, right? Textract, and then here AWS access key ID equal to, we need to provide that AWS secret access key equal to, we need to provide that, and the region where I am interested to call the Textract service. So here I can provide the region as US East 1, and access key ID and secret key we need to provide. So for that I will go to security credentials and I'll scroll below. Here I'll click on create access key. I understand this. Click on create, copy the access key and paste that here, copy the secret key and paste that here. Okay, now we will print the response part. So let's run it and let's see how it is working, or if it is throwing some error we will try to debug it. Okay, and here you can see it basically returned us the response, and it is a very big JSON kind of thing. So what I will do, I'll copy this whole JSON and I will try to parse this using JSON formatter available in online. Okay, so here I will copy this complete content, and here I will open some online JSON formatter, and then I can open this link. I can paste the JSON whatever our Textract Boto3 client has returned us, and let's inspect this, that how to extract our region of interest. That is, here specifically we are interested in this kind of lines, that the purpose of Apollo 11 mission was to land men on lunar surface and to return them safely on Earth, like that. Okay, so here this is the formatted JSON. Let's expand this. So initially we are having blocks and this document metadata are not needed. Let's reduce the blocks, and at the end we are having some metadata, so this also not needed. So our required information should be available in blocks, and here block type is page, so let's minimize that, and maybe first whole element I can minimize, because here in the first element we have not found our required text. But here if you see, when block type equal to line, this thing is started. Here our required region of interest is providing. The purpose of Apollo 11 mission was to land men on lunar surface and to. Okay, so if you see the first line, up to that only it is available, and to. The next line is return them safely on Earth, blah blah. So here see the next element, and when block type is line, and here you can see this printing the next element, that is return them safely on Earth, full stop. The members of the crew were Neil Armstrong, etc., etc. So here you can see return them safely to Earth. The members of the crew were Neil Armstrong, etc., right? So basically we understood from this particular JSON inspection is that within our response we are having blocks key, and there we will iterate because it is an array, and we will try to find out whether block type equal to line or not. If block type is line, we will extract the text part and we will continuously append. That way we will get the OCR response or extracted text from the image. Okay, so here what I will do, I will basically clear all output, and here I will write the next part of the code. So here I can define a variable extracted text equal to empty variable, and then we will iterate maybe for x in. Here if you see in our JSON, the main key is blocks, right? So it is stored in response. So response of blocks, right? And here I will put a colon, and then here individual item will iterate if the block type is line. So here I will put a if condition, if x of block type equal to line, and make sure we are putting proper case. So here line is in caps, so I need to use that only, line. Then what we'll do, we'll append the data in extracted text. So extracted text class equal to, we'll put a space, and then we will append the content. Okay, so the content is nothing but in the array element x, which part we need to extract? We need to extract the text key, right? So here we can put this. So this is how the complete extracted text after this for loop completion will be available in this variable. So let's run it and let's see. So here we are getting some text. I will copy this complete thing and I'll paste in Notepad++. And now let's compare whether our Textract service has properly extracted the text data from the scanned image or not. Okay, so here if you see, the purpose of Apollo 11 mission, was to land men on lunar surface. So it is like that, properly working, right? If I scroll below the last paragraph, let's inspect. So here also in Notepad++, I will go to the last paragraph and I'll just try to squeeze this little bit. Here we are getting the last line: as with the completion of Apollo 11 mission, the national objective, landing men on moon and returning them safely to Earth before the end of the decade, has been accomplished. And if you see our image, the last paragraph is: with the completion of Apollo 11 mission, the national objective, landing men on the moon and returning them safely on Earth before the end of the decade, has been accomplished. So that means is properly able to extract the text information from this scanned image, right? And now I hope to implement any RAG system using generative AI, what we have to do, that approach is clear to you. Basically, we have to split this text into small chunks using character text splitter, and then we have to pass those small individual chunks via some embedding model, using which we will get the vector representation of it. We will store in some Pinecone vector database, and then whenever user will ask some query, we will try to find out the similarity of that query vector with the existing chunks. Whatever related chunks we'll be getting, with that we'll append the query and pass to our LLM model, and the LLM model will try to reply based on that, right? So this is how we can utilize the power of AWS machine learning service, AWS Textract, and the generative AI concepts to build RAG application on top of image or scanned PDF files. Okay, so I can show you another example. So we are having another PDF file. Let me open that. So here we are having one particular PDF file, kind of a scanned PDF. We can say these are not text which we can basically easily read. We need to apply Textract, right? And this document is related to Yogi Adityanath government's plan to transform UP and grow its economy, right? What are the 9 strategies the government is planning for a nation's growth along with the state improvement? Related to that, the informations are provided. Like for example, MSME improvement, emerging technologies, one district, one product concept, right? And then technology parks, how they are helping the farmers. Related to that, the information is available. But these, I hope you can clearly understand, these are image, right? But this is in form of PDF. Now from this PDF image, if you want to train a RAG application, then first you need to extract the text out of it, and then only you can split that text into chunks and store in VectorDB, and then train your generative AI model based on that. Correct? So now let's see whether Textract successfully able to extract the text part of it or not. Okay. So here what I will do, I'll go to my repository, and here I will upload this particular PDF image as well. So here we are having our PDF file. I will copy this name of this file and I will just update here. Okay. And then I'll run this code. So here again, it gave a very big JSON data, which Textract basically returned. So now I no longer need this output because already our code is written. So we are just only interested with the extracted text part. So after formatting, after running this for loop, we are getting this thing. So let's see whether this text is properly aligning with our PDF file or not. So here if you see, the first line is Yogi government develops 9 strategies to transform UP into nation's growth engine. So here if you see 10G government, so obviously you can understand it will not be 100% accurate because these are machine learning models, right? But still it should be sufficiently accurate enough so that if we pass this information via LLM, it can reply based on that. Okay, so here 10G government develops 9, also it has not read properly. There's some II coming, and then strategies to transform UP into nation's growth engine, right? So this part almost it is correct. Now let's see the next line. Here CM Yogi focuses on making UP the best state not only in the country but also in the world, published on this date. So here if you see this line, CM Yogi focuses on making UP the best state not only in the country but also in the world, and here it is written published on, let me just zoom this. Here you can see 2023-8/18. So this date also it has extracted properly at 6:09 p.m. That also it has extracted by press release. So by press release. Then here there is one image of our Yogi government is there, so that the Textract has ignored. And here again it started text extraction. Lucknow. The Uttar Pradesh government is working on a strategy to make the state a $1 trillion economy and has diverse plan of 9 core issues. So here if you see Lucknow, the Uttar Pradesh government led by Chief Minister Yogi Adityanath is working on a strategy to make the state a $1 trillion economy and has diverse plan based on 9 core issues. So that means this particular text file is perfectly aligning with this PDF whatever we are having. So this way I hope you understood that Textract is a very good service if you are having some images and you want to extract the text out of it and then train your machine learning model or advanced generative AI foundation models for RAG application, or to make some Q&A chat application based on PDF which are in form of image, right? So I hope you understood this part, and in our next section we are going to explore how to build a complete RAG application end-to-end using this Textract service, which basically utilize the power of optical character recognition for text extraction from any image or PDF or TIFF file or PNG file, etc. Okay, stay tuned. So now we are going to implement the concept of Textract, that is OCR based text extraction from PDF image or normal JPG or PNG image, and using that extraction we are going to build a RAG pipeline. Okay, so let's explore the system design component first and then we will jump into the practical section. So first we will be having some documents in S3 that can be scanned PDF files or images like JPG, PNG, etc. format. Now to implement a RAG system using this particular dataset as a source data, what we can do, first we will apply OCR using Textract and we will extract all the text whatever is available in this scanned image or normal image. We will pass those extracted text via some embedding model to get its vector representation. Okay, obviously in middle we will be applying chunking, so what we discussed using characters text splitter in our previous video, and that small chunks of the extracted text we will embed, and the vector representation will be storing in some sort of vector database which will be acting as a knowledge base for this RAG application. Okay, and here if you scroll below and check this particular section, this is user facing. Okay, maybe you are building some Q&A bot, so the user will be asking some question, maybe using some API you can trigger your lambda function, and that lambda function will take the user query. First it will get its vector representation using embedding model, okay, and then it will try to find out what are the similar vectors available related to that particular question vector in our vector database. And obviously it will be using cosine similarity in the backend. The vectors which are having higher similarity, those chunks it will be extracting, it will append with that question. So here basically we'll pass question and relevant information which we have extracted from this knowledge base, and then we will pass that via some LLM model that can be Titan, Text, V1 like that, and we'll get the response out of it, and that response using API gateway will return to user. Okay, so this is a typical flow if you want to build a RAG pipeline on top of scanned document or images. So now more or less we understood the pipeline flow. So what we'll do as a first step, we'll implement this whole Python code, like for this particular lambda whatever Python code will be there, and for this lambda whatever Python code will be there. Both Python codes first we will be creating using Google Colab, and then we will implement this pipeline end to end first. Eventually, if required, we can convert that Python code easily to a lambda function and we can deploy it in our production system. Okay, right? So without any further delay, let's directly jump into the practical section. So here we need some scanned image or PDF files. So for that I am going to take this particular PDF image only, that Yogi government's 9 strategies to transform UP into nation's growth engine. So here you can see this is nothing but an image, right? Now on top of this, if you want to create a Q&A bot which will basically reply based on the information which are available in this particular PDF scanned document. So what we need to do, first we need to create text document out of it, right? So here we will do that first. So that particular PDF file here I have already uploaded in my S3 location, and here what we will do, we will run our previous code to just confirm the code is properly working and extracting the required text information from that PDF document. Okay, so here let's run the cells one by one. This is just the same code what we have executed in our session 1 of this particular video. So here Boto3 is installed successfully, and now we can run this particular text extraction using Textract client. So let's see. So here it is also executed, and here we can run this particular paragraph to get the extracted text, and here we can get the text document. Okay, now we will apply RAG on top of this extracted text. Basically we'll implement this particular pipeline. So first we have implemented OCR, we got the text data in a variable, and now we will basically split that bigger text into small chunks. We will embed them using some embedding model, and then we will store their vector representation in our vector database. So for this particular discussion, again I am going to use Pinecone as our vector database. So I'll just create an index. Maybe I can give the name as demo yt Textract. Okay, the dimension obviously 1536, because the embedding model from Bedrock what we are going to use, the Titan embedding model, always provide 1536 dimensional vector representation for any chunks, right? And here, keeping all other properties default, I will create this index. Okay, cool. And apart from that, for this particular demo we need an API key also, so I'll create this API key, demo text. So here it is also created. Now we can copy the code from our previous video and create a RAG application on top of this extracted text. Okay, so here I can go back to the code which I explained in my previous video on how to create a RAG pipeline on text data. So for this particular discussion, apart from both of three, we need LangChain and LangChain Pinecone as well, because we are going to use. So here I'll run this thing, and then here what we are doing, we are creating the Boto3 Bedrock client as well. So I'll do that. So here I can scroll below and create a paragraph and Boto3 client. So here import OS, just for safer side we can put, and then import JSON also, because it will be needed to parse different response. So that we have created. Now here Bedrock runtime, region name US East 1, access key and secret key we need to provide. So access key, secret key I am going to copy from my Textract client, not a problem. So here this part is more or less done. I'll execute this particular cell as well. Now let's go to the next step. Here what we are doing, here we are importing some required modules, like for reading the text data for LangChain we are going to use text loader. Then Bedrock embedding we are going to use for embedding individual chunks what we are going to create from this text, and then character text splitter will basically help us in chunking the document, right? So all these things we'll do. So here I will go to the next cell, and here what we did earlier, we basically read the file from my local system. Okay, so here I will copy this particular thing and I'll paste that here. Okay, now here we need to do a small change. Like here if you see, this particular text file already we kept available in our Google Colab notebook in our earlier video, but currently this extracted document is not available in some text file, it is available in a variable. So let's modify this particular code little bit so that the information will be stored in a text file instead of in a variable. Okay, so here I can give output file name equal to, and here I can give demo rag on image, okay, .txt. So this will be a text file, and the same code will be encapsulating within a with block, where the with block will basically help us to write the content in this output file. Okay, so here we'll open the output file. So here output file name, and then here we want to write the data. So I will open in write mode, and then as output file IO. So IO operation we are going to do, and then here what we'll do, for loop, let it be as it is. So this variable is no longer needed because directly we are going to store in this output file. So for x in response, if it is line, so here we were appending that information in a variable. So here what we'll do, we will basically store the same information, instead of variable we'll store in this file. So output file IO dot, using write operation we can write the data, and what we should write, basically within this x variable we are having the key called text. So the text will be extracting and that will be appending in an output file. Okay, so text is nothing but here individual lines. Okay, so in between two lines we should be separating with /n or new line character. So that also will be doing. So not only I will write the text, but I will also add a new line character after each text line. Okay, and this print statement is no longer needed, so I can close this one. and we need to put the indentation properly, so I'll just make it correct. Okay, so I'll run this cell, and here if I refresh, currently here you can see in this particular directory there is no files with this name. What we'll do, let's run this code and let's see whether it is working or not. So here this cell is executed. If I refresh, here you will see demo rag on image text file is created. Let's open this file and let's see whether it is giving the proper format or not. So here if I just put this particular thing somewhere, so here you can see one particular paragraph is there with Lucknow. The Uttar Pradesh government led by Chief Minister Yogi Adityanath is working on a strategy to make. So this is one line. And here if you see in our text file, the Uttar Pradesh government led by CM Yogi Adityanath is working on a strategy to make, right? So exactly the text are extracted from this particular scanned PDF file in the same manner how it is available here. Okay, due to application of new line character, right? So now our output file is ready. All we have to do, we can remove this particular line and we can copy this particular path of the file where the extracted text is available, and that we can read. As simple as that. Okay, so here I can run this particular code. Minimize this PDF file as of now, and here it failed. Text loader is not defined because we have not executed this cell. So let us execute and then run this cell. So here split docs is created properly. So let's see our splitted chunks. So here you can see this is how our splitted chunks look like, and individual chunks here basically indicating some part of our original PDF scan document. Like these core issues include important matters such as emerging sector alongside agriculture, rapid urbanization and industrial infrastructure. So here if you see, that same thing is available. These core issues include important matters such as emerging sectors alongside agriculture, rapid urbanization and industrial infrastructure. So what I'm trying to say is basically here we have implemented chunking part of our RAG pipeline generation. Now we can go to the next step. So here let's see what we are doing. So here we are defining the Pinecone API key. So I'll copy this API key and I'll paste that here. I'll go to the next cell. And then here we are creating the embedding model for our Bedrock, and we are importing the Pinecone vector store from LangChain. The index name we need to provide. So in this case, for this demo, this is the index name what we have created. I'll paste that here. And Pinecone vector store from documents. Here we are passing our individual chunks and the embedding model, which the Python code will be basically using to convert the chunks into vector, and then it will store in this Pinecone index. Okay. So we'll do this complete process. As of now, here you can see there is no records, and I'll just run this particular cell. It is going to take some time because all these chunks it will be converting to a higher dimensional vector representation and will store in Pinecone. So here it took 6 seconds and the code is executed. And here if I refresh this particular page, here you will see in our Pinecone index, individual chunks are stored in a vector represented format. Here if I scroll below, here you can see that by press release, the Uttarakhand government led by CM Yogi Adityanath is working on a strategy to make blah blah. So here what I am trying to say is, till now the vector store part, that is up to this particular part, the job is done, right? So what we have done, we have extracted the text from our scanned PDF file using OCR. We have passed those small chunks using embedding model. We got its vector representation and stored in our Pinecone index, which is acting as a knowledge base for this RAG application. Right? Now here what we'll do, we'll go to the next step. So the next step is user facing. So let's see what we have done in our next step. So here basically I tried to show you one particular example of similarity search working or not. So we can ignore that as of now. I can copy this prompt part. So prompt part here what we are doing, we are instructing the RAG application that these are some related chunks and this is the human question, try to reply based on that. So we can run it safely. Right, and now import JSON already we have done, and this is one complete sample code. So here what we are doing, let me just explain you line by line. So first we are taking the question from human, and then here we are searching in our Pinecone what are the top 3 chunks related to this human question input. Okay, and human question will be obviously in text format. But here when similarity search is implemented, it basically try to find out similarity between vectors. So how this particular human input from text will be converted to vector representation? It is nothing but using doc search. So here if you see, we created doc search. Here we have configured the embedding model, right? So that power we are using. But here is a catch. It is like doc search, how we have created? Here we have created when we try to insert the data in our Pinecone vector store, right? That means when we have implemented this particular part, that time the doc search component we have created. But it is not like whenever user will ask question, that many times we need to implement this first half. Okay, it might be possible that the first half we are doing once in a week, something like that, the vector database data refresh. But the user can ask questions anytime. So we should be implementing the code such that the code will work on some existing vector store as well. It is not like again and again we need to refresh our vector store and then only the object whatever we'll be getting, on top of that we can apply our DAG application, right? I hope you are getting it, that on existing system we should be able to implement this code, not always after data refresh. So for that, here I will go to Google and let's see how to write that code. So here I can write LangChain on existing Pinecone index. Okay, so here we can go to this particular GitHub query. Let's see if someone has written something or not. I actually figured out if anyone needs the code, this is the code. Okay, so we can create the docstring like this way. So here this is the code. What we are doing, Pinecone dot from existing index. So this particular method we have to use. Index name we have to provide, an embedding model what we need, that we need to provide. So in our case, the embedding model is basically this thing, Bedrock embedding, right? So that will update, and index name is already stored in a variable, and we can run this particular scene. So here Pinecone is not defined. So here let's see how to import. So here I can write import Pinecone and search, and here we can see this is how we need to import. Just paste that from LangChain.vector store import Pinecone. Okay, and then using this particular method we can basically query or find out similar items from some existing index. Okay, so here I can give some different name, maybe existing search, just to show you the demo that here we can search on existing index, and instead of doc search I will put existing search. Okay, so let's run this cell. It is executed successfully, and here what we have done, we are first trying to find out top 3 similar chunks available to our vector database or knowledge base related to user question. We are appending all of them. We are creating our prompt using prompt template, whatever we have configured earlier. Here we are passing the context and the human input both, and we are asking for reply. Okay, now this is basically a prompt. Now we need to pass this particular question to complex generative AI foundation model, right? So for that we are going to use Amazon Titan Text Express v1. So this is a typical code how we can ask any question to our LLM model, right? Generative AI model. So that same code I have used, and after extracting the output we are printing it. Okay, so let's run it, and we will ask some question from this PDF file. So let's see. In a presentation of World Bank representative Deloitte India, which is working as a consultant to help Uttar Pradesh become a $1 trillion economy. So here I can ask that kind of question. Which company is helping UP to become $1 trillion economy? Okay, so let's ask this question, and here you can see Deloitte India is helping UP to become a $1 trillion economy. Generally, if you directly ask to any chat GPT or foundation model, they will not able to reply. But this is RAG, this is trained on our existing data, and that also we moved one more step. It is not a simple text file, it is a scanned PDF image kind of thing, right? So first we have extracted text using OCR, that is one machine learning approach, and then we are implementing RAG, which is another powerful machine learning or AI approach, right? So combining two powers, we are getting this beautiful result. So here I can ask one more question, that basically UP government is working on ODOP. They brought this concept, one district, one product. That is whatever district is famous or powerful in building some product or food, etc., or crop, etc., they will focus on only that part. First they will detect district by district which product is popular, and then they will put their very high attention on that particular thing and try to attract market out of it. So that concept is ODOP. Nowadays many states are following this concept after UP government successful implementation. So here we can ask about some ODOP. So here explain little about ODOP. Okay, so here you can see ODOP is one district, one product, where every district in the state focus on producing one specific product, promoting local economic and creating a unique identity for each region. Not only economical growth, but you are getting an unique identity using one district, one product concept. Right? So here I hope you are getting it, that we successfully implemented a RAG pipeline on top of our scanned image. Right? First we have implemented OCR, and then we followed the normal approach, whatever we followed for RAG pipeline implementation in our previous video. Right? So I hope you understood the power of Textract service provided by AWS. Try to play with this particular service. You can make awesome projects out of it. So this is all for this particular section. Thank you for watching.